When we studied linear regression, we assumed a linear model for how the data are generated and then estimated the parameters that are defined by that model. But how do we assess how reasonable it is that our observed data are actually described by the model? This is the realm of hypothesis testing. Let's start by thinking about a simpler scenario. Consider the following. Ohio and Pennsylvania are similar states. They are neighbors, and they both have liberal urban counties and lots of rural conservative counties. I hypothesize that county-level voting in these two states have identical probability distributions. We have voting data to help test this hypothesis. Stated more concretely, we are going to assess how reasonable the observed data are, assuming the hypothesis is true. The hypothesis we are testing is typically called the null hypothesis. We might start by just plotting the two ECDFs of the county-level votes. It's pretty tough to make a judgment here. Pennsylvania seems to be slightly more toward Obama in the middle part of the ECDFs, but not much. We can't really draw a conclusion here. We could just compare some summary statistics. Again, this is a tough call. The means and the medians of the two states are really close, and the standard deviations are almost identical. So eyeballing the data is not enough. To resolve this issue, we can simulate what the data would look like if the county-level voting trends in the two states were identically distributed. We can do this by putting the Democratic share of the vote for all of Pennsylvania's 67 counties and Ohio's 88 counties together. We then ignore what state they belong to. Next, we randomly scramble the ordering of the counties. We then relabel the first 67 to be Pennsylvania and the remaining ones to be Ohio. So we just redid the election as if there were no difference between Pennsylvania and Ohio. This technique of scrambling the order of an array is called permutation. It is at the heart of simulating a null hypothesis where we assume two quantities are identically distributed. Let's look at how we can implement this in Python. First, we need to make a single array with all of the counties in it. We do this using the np.concatenate function. Notice that this function takes a tuple of the arrays that you wish to concatenate as an argument. Next, we use the function np.random.permutation to conveniently scramble the entries of the array. We then assign the first 67 to be labeled Pennsylvania and the last 88 to be labeled Ohio. These samples are called permutation samples. Now let's practice doing some permutation sampling on real data.